Welcome surfers, it is Joel and this is Rustlers Atom 2.4. In today's video we talk about the borrow checker. If you haven't subscribed to this channel yet, maybe can be the right time to do it to support this work and to support Rustlers. Starting to program in Rust means in early days fighting the borrow checker. The borrow checker is the part of the compiler that feels like an annoying programming teacher. But it's the only reason Rust can guarantee memory safety without needing a garbage collector. The borrow checker operates on two strict, non-negotiable rules to prevent data races. A data race is what happens when two pointers access the same memory and at least one is writing and there is no synchronization. This condition is a real nightmare in the debugging phase. Let's talk about the law number 1, the validity rule. In Rust, references must always be valid. You cannot have a reference pointing to memory that has been freed. This is called a dangling pointer, and in Rust is not permitted. Let's do a practical example. I can create R, a variable, R, okay, and I can create a scope using brackets. Inside the scope, we can create another variable, x equal to 10, x, okay, and we can try to set a pointer to point to x. So R point to the reference of x. Perfect. And now at the end we can print our R value. R. Perfect. Let's say what the compiler do in this case. Print line, okay, I forgot that print line is a macro, it's not a function. Okay, as you can see, the borrow checker have something to complain and this code do not compile because a value is borrowed here but is dropped here when the scope ends because I close the bracket. If I remove the scope used only for test, the code compile without any error. This is why in this point x is gone, so R would be pointing to dead memory. If we use C++, this might be a segmentation fault, but later, during the execution of the program. In Rust, this code simply doesn't compile. This first rule is intuitive, but the law number 2 is the one that trips people up. It's the aliasing versus mutability rule. At a given time, you can have either one mutable reference or any number of immutable reference. Never both together. Let's write an example. I can write rule to valid. Let's create a value, overloaded 42 integer. Now I can create an infinite number of readers of this value. So let a equal to value. Let b equal to value. Let c equal to value. Okay, and now I can use all this value together. So print line readers 1, 2, and 3 things. A, B, and C. Okay. Let's try this code. As you can see, the compiler don't have anything to complain. I have 3 different readers, and I can have 1,000, 1 million of different readers without any problem. At any given time, you can have either one mutable reference or any number of immutable references. Never both together. Let's write an example. So, rule to invalid. I can create a mutable value. Let mute value 2 is equal to 42. And now I can try an immutable borrow. Let R1 equal to borrow the value. And I can also try R2 a mutable borrow. So ampersand mute value 2. Okay. And now I can try to print these values. Readers 1 and 2. R1 and R2. Okay. Let's take a look to what the compilers say. Immutable borrow occurs here when we create the R1 reader, and mutable borrow occurs here when we create the mutable R2 reader. This in Rust is not permitted, but why is this so strict? Imagine you have a pointer reading the data and another pointer writing to it at the exact same time. If that writer resides a vector, for example, it might move that data to a whole new memory address to make the room for new values. In this case, your old reader pointer is now looking at nothing, at garbage values. So, in Rust, if you have a mutable reference, you have strict exclusivity. No one else is reading, no one else is writing. All of these catches bug at compile time, and this bug can be a security vulnerabilities in another language that permit this kind of dangling pointers. For this video it's all. See you in the next atom, and don't forget to subscribe to the channel and to keep your thinking cap on.